Hey guys, in this video we're going to be looking at angle measures and terminology that goes with those angle measures. So let's begin. The angle. You probably remember in geometry that we define an angle as two rays meeting at one point. So this point we call a vertex. This is the endpoint of the two rays. So writing this down. An angle is, often said to be two rays with a common endpoint. And that is still true, but why not think of angle measures as a measure of rotation or turn? That's technically true for us still. An angle measure is two rays with a common endpoint, but why don't we think of the measure of an angle to be the measure of a turn? So we're often going to see kind of this within an angle measure representing the angle's turn, the ray's turn. And we use the Greek letter theta. The Greek letter theta to represent the angle's measure, whether in degrees or radians. And it's just like a circle with a little line through the center. This is the Greek letter theta. So angles, when we say to put an angle in standard position, what are we actually talking about? Is the vertex, this is often seen as a XY axis. The vertex will place on the intersection of the two. And what we consider to be the initial side, the base of the angle, it will lay along the x-axis always in this direction. And we measure the angle around, and this portion of the angle where the angle stops, we call this the terminal side. The terminal side of the angle, and our angle measure is there. So again, this gives us a better picture of how we think of angles as a measure of turn. So this terminal side is moving around while our initial side is remaining still. And quadrants, this is what you think it is. It's just the quadrants. We're going to do some interesting things with quadrants. So we need to know what the quadrants are. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And something else to think about is there is a 90-degree measure within each of these regions. So we have 0 degrees, we have 90 degrees, we have 180, 270, and yes, we can go back to 360. So this is in degrees. In radians, write this in a different color. In radians, if we do not know this already, 90 degrees would be pi over 2, and then 180 would be pi, 270 would be 3 pi over 2, and 360 would be 2 pi. All right, so we just need to know this, where the certain angle measures are placed on the axes and where our quadrants are. So we're going to do some interesting things, like where would the angle measure of 48 degrees be? So 48 degrees. So it's between 0 and 90. So we would say it's roughly right here. Not bad. So where would the angle measure of 300 be? So we have 90, 180, 270, 300 we know to be in this area. So just doing our best to approximate where that will be. And that would be 300 degrees. It is important for us to actually write this turn, kind of say this circle. It's important for us to do that. We'll see why as we explore this more. So knowing the quadrants, so a 300 degree angle is in quadrant 4, a 48 degree angle is in quadrant 1. All right, so with that understanding, let's actually draw some angles. So let's draw an angle that's 315 degrees. All right, so remember 0, so we have 0, 90, 180, 270, 360 is back at where we were. And as I almost forgot, we need to draw our initial side on these. We need to draw that initial side, and then our terminal side would be right about here. So 315 degrees. Let's try another. What about negative 150 degrees? So you're noticing already within this little lesson that our angle measures are now over 90 degrees. When we were dealing only with triangles, all of our angle measures were acute, under 90 degrees. Now we're seeing we can have angle measures like 315 degrees, and we can have angle measures that are negative. So the negative simply means the direction we are turning. So we still have our initial side. So negative, we are turning not in the typical fashion, but we're turning the opposite way. So we have 90 here, not quite 180. So we have a negative 150 degrees. All right. So let's try one more of these. What about the degree of 460 degrees? So we know initial side. So we know that if I go 90, 180, 270, 360, I'm actually going to go past 360. And if I take 360 away from this, that leaves me with 100 degrees. So now I know where 100 degrees is going to be. It's going to be in quadrant 2, right there. And yes, we will need to show how this angle rotated about. So this is going to be 460 degrees. So if we were only to put this little portion of the turn, it would be difficult for us to know that it's 460 degrees relative to 100 degrees. They are technically the same measure in a sense, but as far as the rotation, they are different. So let's say we want to name some angles. So let's say we want to name, okay, so you have this angle measure. So we want to name that angle. Well, we know rotating about this direction, I guess this would be what? Clockwise direction? The typical is counterclockwise. So you could say that this is, first of all, negative 120 degrees, representing the change in direction. Or we could say that we're going in this direction. What would that be? So we know the full term would be 360. So if I take 360 and take this 120 away, we get 240. So I could also say that this measure is also 240 degrees. All right, let's try another. So let's imagine for a moment that we have but rather than knowing this measure, we know this measure. Okay? Should be rather easy. So we know the full was 180 degrees. So I could argue, this measure would be whatever we get from 180 taken away the 45. And I believe that's 135. So this angle could be 135 degrees. Or we could argue that this angle measure is, well, coming the other direction with a negative 180 plus 45, that would be 225. So the common thing is we're able to name angles with a positive and with a negative representing that. And one more of these. Let's say we have, okay, and we're doing this sort of thing, and we'll say this portion is 60 degrees. Well, right away, knowing how the direction changed on us, we can write down that this is negative 60 degrees. Or in the other sense, with a positive measure, we would say that this would be 360 take away the 60, or just 300 degrees. So positive measure, negative measure to represent one angle. So this idea that we're able to have a positive and negative angle measure to represent one angle, or even just multiple measures for one angle, there's a term for that. But before we move on, I want to write this down. Every angle can be written with a positive and a negative measure. So we're going to expand on this more as we continue on to something called coterminal sides. So coterminal sides, how do we define this? So two angles are coterminal if they're angles that share a terminal side. Okay? So just let's examine this for a little bit. Typically, if you're looking at coterminal angles, you'll be given an angle measure and you'll be asked for a coterminal angle. So let's say we have we're seeing this here, and it's written as we're given negative 130 degrees, and we desire a coterminal angle that is an angle that is between 0 degrees and 360 degrees. So essentially we're looking for a positive angle measure. So if I desire a positive angle measure, well, I could add 360 degrees to this. That would essentially just bring me back around this way, so it'd bring me like this. So adding 360 degrees to this would give us an angle measure between this range. So that would be 360, take away 130, that would be 230 degrees. And that would be a coterminal angle. That's between 0 and 360. So then let's look at one more. Let's say we have, this here, and we have an angle measure in radians this time, okay? It's 3 pi over 4. All right, so this might seem a little difficult to you, but for this one, let's desire an angle that's one positive, and then the measure that's a negative. All right, so the idea of adding 360, that would still work for us. So in radians, we know 360 is 2 pi. So I'm going to take 3 pi over 4, add 2 pi to that, because it's mental math. 2 pi, that's actually 8 pi over 4. So that would become 11 pi over 4. That is a positive measure that's coterminal to this one. And if I want a negative measure, I would simply take 3 pi over 4, and let's take away 1 full rotation. So we take away 2 pi. So again, 2 pi is 8 pi over 4. So 3 minus 8, that's negative 5 pi over 4. So 1 positive, 1 negative. And we got each of these by adding 2 pi and subtracting 2 pi, because 2 pi in radians is 1 full rotation. So let's say we have an angle of, going back 2 degree, an angle of 30 degrees. So let's say I want all coterminal. I want a way to find all coterminal angles. And if I want a positive coterminal angle, we saw we were going to add 360. If I want a negative coterminal angle, we kind of argued that we're going to subtract a full rotation, which is subtracting 360. So we would say 30 degrees. If I want every coterminal angle, I would simply add 360 in certain increments. So this is n. So I can take add 360, add 360 again. I can add 360 10 times, and it would still be coterminal. Or we can take 30 degrees and subtract 360 a certain number of times. So doing so would give us every possible coterminal angle. So we're going to end this lesson and this video by doing, really, the whole purpose of this lesson is taking an angle measure and reducing it back down to between 0 degrees and 360 degrees. So we're taking one angle measure and reducing it back down. So this angle measure, we are doing 960 degrees. Just put it right in here. So this is 960 degrees. We want to reduce that back down to 360. So I encourage you to pause the video and give this a shot and see how you do. Okay, so let's see. So 960. We want to keep taking away 360 until we're back within that range. So 960 degrees, we take away 360. That leaves us with 600. We take away 360 again because we're not within that range, and we get 240 degrees. And there we go. So a 960 degree angle measure is the same as a 240 degree angle measure. All right, so talking about angle measures, and we're going to expand on this applying trig, but I wish you the best of luck with the practice problems, and we'll see you next time.